In this video, we're looking at problem solving using quadratics. The question says, if these two rectangles have the same area, what is the value of x? And we have our two rectangles with labelled lengths and widths. And we have our general formula for solving worded quadratic problems on the right-hand side here. So let's start by labelling our rectangles. The first one is area number 1, and the second one is area number 2. Because what the question is telling us is that area number 1 is equal to area number 2. And we can use that information to form our quadratic equation to solve. Let's start by calculating area number 1. Area 1 is length times width. We can see the length and the width of our rectangle, and we can substitute those values in. The length is 2x plus 4 multiplied by the width, which is x plus 3. And we can expand out our quadratic equation. We get 2x, our quadratic expression here. We get 2x squared plus 6x plus 4x plus 12. Which gives me 2x squared plus 10x plus 12. And that's an expression for the area of rectangle 1. Let's do the same for rectangle number 2. Area 2 is length times width. The length of our rectangle is x plus 5 and the width is 3x take 6. So we have x plus 5 multiplied by 3x minus 6. And we can once again expand that out. We get 3x squared minus 6x plus 15x minus 30, which gives me 3x squared plus 9x minus 30. Now the question tells us that the area of these two shapes is the same. So let's form our single equation that we're going to be able to solve. And it says area 1 is equal to area 2. So our expression for area 1 is 2x squared plus 10x plus 12. And that is equal to area 2, which is 3x squared plus 9x minus 30. Now we need to rearrange this equation into the standard form of a quadratic equation. The right-hand side of the equation has 3x squared and the left-hand side has 2x squared. So to avoid having a negative coefficient on that leading term, I'm going to collect all of my terms to the right-hand side of the equation. So I subtract 2x squared from both sides. And I'm going to also subtract 10x from both sides. And I'm also going to subtract 12 from both sides. I'm doing that all in one step. So on the left, the 2x squared minus 2x squared cancel, 10x take 10x cancel, and 12 take 12 cancel. I'm left with 0 equals x squared minus x, 30 minus 12 minus 42. So I can rewrite that in the standard form we're very familiar with as x squared minus x minus 42 equals 0. And there's our quadratic equation that we can solve, which we now want to solve either using the null factor law by first factorising or using the quadratic formula. Let's use the null factor law for this one. It has 3 terms, so we can use our sum and product method of factorising, or SPF. The two factors we're looking for need to sum to minus 1, have a product of minus 42. And so those two numbers, 7 and 6, are negative 7, positive 6. 7, 6 is 42. So we write that in factorised form as x minus 7, x plus 6 equals 0. The null factor law says if the product of two terms equals 0, one of the two terms must be 0. And so either our x minus 7 equals 0 or our x plus 6 equals 0. If it's x minus 7 that equals 0, x is 7. And if it's x plus 6 that equals 0, x equals negative 6. So now it's time for us to interpret our solution. Either x equals 7 or x equals negative 6 are both valid solutions here. We just need to check that they don't give us any negative side lengths. So let's have a look at area number 1, the width. X plus 3 for the width. Well, if our x is minus 6 plus 3 is negative 3. We can't have a negative width. And so that means we need to ignore or discard x equals negative 6 as a possible solution. And our solution for x will be 7. So therefore, the value of x cannot be negative 6, as we'd have negative side lengths. So we continue to interpret and we say, so x must be 7.